Hello, welcome to this lesson in the Linear Algebra Tutor. We're going to talk about what we call cofactors of a matrix here. Now, I mentioned to you in the last couple sections, I taught you how to take the determinant of a 3 by 3 matrix using my favorite method. I use it all the time. But I also told you that that was a subset of a broader technique. And so here we're going to start talking about the broader technique. Ultimately, you need to understand the broader technique for the purpose of matrix theory. In reality, I actually just use what I've already taught you before, but you will be tested on this stuff and how to find determinants using these different ways. So I need to make sure you understand it. So let's talk about the concept of a cofactor, and then you'll see how it ties into what we're talking about here. We're going to talk about the concept of a submatrix first. And you already really did this. I just didn't really call it that, or at least too much. You know how I was telling you to cross out this column and cross out this row, and whatever you have left that goes into your calculation? That was really what we called a submatrix. I'm just going to illustrate it here a little more explicitly or formally, like you might see it in your book. So if you had a matrix -1, 1, 2, 0, 6, 3, 4, 7, 5, something like that. Let's say you had this guy going on. Then you could form various submatrices. For instance, you could say submatrix A sub 1, 1. This means the location or the submatrix formed by going to row 1, column 1, and then crossing this guy out, just like we've been doing. So we have 6, 3, 7, 5. 6, 3, 7, 5. I'm not doing any determinants yet or anything. I'm just defining the concept of a submatrix. And then we've already done this a lot, so I'll kind of fly through this. A2, 1 would be, or I should say 1, 2. A1, 2, which means row 1, column 2. Row 1, column 2 would be covering this up. So I would have 0, 3, 4, 5. 0, 3, 4, 5 because I'm covering this guy up. And A1, 3 is the submatrix formed by taking this element and covering this and covering this. So I have 0, 6, 4, 7. 0, 6, 4, 7. Now, to be absolutely explicit, see, what we've done here is I've defined the same submatrices that I've been using with you by going through this first row. But you can define a submatrix by going through the second row, too. This is how it starts to get a little broader than what I've taught you. So A2, 1, which means row 2, column 1, is this element, row 2, column 1. So if I look at the intersection, I would cross this out and I would cross this out. So I would cross this out and this out, 1, 2, 7, 5. See, that is that's a valid submatrix here. 2, 2 would be this middle element here, and I would cross this guy out and this guy out, so I have -1, 2, 4, and 5. Basically these guys around here because I